For 4 centuries, we have looked for life by following the light. Europa is the argument that we had it backwards the entire time. A moon smaller than our own, wrapped in an ice shell roughly 15 miles thick, may hold twice the liquid water of every ocean on Earth combined, and not one drop of it has ever seen the sun. In October 2024, NASA launched a spacecraft the size of a basketball court to go ask that water a question. The Clipper will not land. It will not drill. It will fly past Europa 49 times, threading a radiation belt that would kill a human in 20 minutes, sniffing the thin exhalations of a world that should, by every textbook definition, be dead. The premise of the mission is quiet and radical. If something is alive down there, the rulebook we have been using to search the galaxy is wrong. Start with the shell itself. Europa's surface is the smoothest solid object in the solar system. Fewer craters than a fresh skating rink, scored instead by long reddish fractures the Galileo probe mapped in the late 1990s. Those cracks are the giveaway. They open and close on a tidal rhythm, pulled by Jupiter's gravity, and the rust-colored stains inside them are salts. Salts that came from below. Beneath the ice, somewhere between 10 and 30 kilometers down, sits an ocean estimated at 100 kilometers deep. Read that number again. The deepest trench on Earth is 11. Europa's ocean floor presses against a rocky mantle that flexes as the moon is squeezed and stretched on every orbit, and that flexing generates heat, not sunlight, friction. The story goes that this single mechanism, a moon being kneaded like dough, could be enough to keep an entire biosphere warm for billions of years in total darkness. Friction needs somewhere to go. On Earth, the closest analog sits along the mid-ocean ridges, where seawater meets magma and erupts back out at 400 degrees Celsius through chimneys of black sulfide. In 1977, a submersible called Alvin found these vents in the Pacific and saw something nobody had predicted. Tube worms, clams, entire reefs of animals living on chemistry instead of photosynthesis. No light reached them, no light ever had. The base of that food chain was bacteria eating hydrogen sulfide, and the discovery quietly rewrote what the word habitable was allowed to mean. Europa's seafloor should, by every model we have, host the same kind of chimneys. The mineral chemistry is right, the pressure is right. The energy budget, derived from tidal heating measurements, is right. Some theorists suggest the vents there could be larger and longer lived than ours, because the moon never stops being squeezed. Here is where the mission gets clever. You do not need to drill through 15 miles of ice if the ice does the work for you. In 2013, the Hubble Space Telescope caught something venting from Europa's south polar region. Water vapor, 200 kilometers high, geysering into vacuum. The observation has been repeated, contested, repeated again. The plumes are intermittent, faint, and exactly what you would expect if the ocean below is occasionally cracking through to the surface. The Clipper was designed around that possibility. Its instruments include a mass spectrometer that can identify organic molecules at parts per billion, a dust analyzer that can catch grains of ice mid-flight, and a thermal imager that hunts warm spots on the surface where fresh material has recently erupted. On every flyby, the spacecraft will drop to within 25 kilometers of the surface and taste whatever the moon is breathing out. No drilling required. Imagine the spectrometer returns a clean signature, amino acids in non-random ratios, or methane paired with something it should not coexist with. The implication does not stay on Europa. It propagates outward. The habitable zone, that thin ring around a star where liquid water can sit on a surface, becomes a planetary science footnote rather than a law. TRAPPIST-1, the seven-world system, 40 light-years away, stops being a curiosity of rocky planets in a narrow band and becomes one of thousands of systems where the interesting real estate is underground. Every icy moon, Enceladus, Ganymede, Callisto, Triton, possibly Pluto, joins the list of candidates. The numbers of potentially inhabited worlds in the galaxy does not double. It increases by orders of magnitude. And our own situation, a thin film of life clinging to a planet's sunlit surface, gets reclassified. Not the standard, the outlier, the dark, pressurized abyss becomes the default address for biology. And we are the strange ones. If Europa answers yes, the search for life stops being astronomy and becomes oceanography on a galactic scale. The Clipper arrives in April 2030. Until then, we wait, and we reconsider what a world has to look like to be alive. If that reconsideration interests you, the next piece will look at what the Voyager probes saw at Triton and why nobody has gone back.